So one of my projects for work involves operating a machine called the plantoscope. For our purposes, it's basically a Raspberry Pi computer with some additional software and operating system config files. I customized my own plantoscopes by making changes specific to my work. But it became annoying to maintain these changes because the only way to apply updates from the plantoscope project was to back up my data and keys, reflash each Pi with a new SD card image, and then copy over my keys and redo all my customizations on top. So I wanted an in-place update mechanism with a simple, clean, and composable way to manage deployments on my Pis, both in terms of what things are deployed and what versions of those things are deployed. And I wanted the solution to make it easy and robust to undo or redo any change just by switching to some commit of some Git repo. There are some Linux distros which solve various aspects of this kind of problem, but the plantoscope project needs to stay on the Debian-based Raspberry Pi OS for various reasons. So I've built a tool called Forklift as a pragmatic compromise between the reliability, composability, and rigor enabled by modern technologies versus the need for incremental migration and compatibility with traditional Linux distros. Now I'll show you how I've been using Forklift in the plantoscope project, but through a simplified demo. So here I'm connected to a browser terminal on a Raspberry Pi which has a demo palette applied to it. A palette is just a Git repo with a declarative configuration of all the Forklift managed software and files to be deployed on a computer. This one includes a Hello World Docker container. And the container serves a web page on port 80, which we access via the Pi's hostname. With Forklift, software and files are modularized as packages published in Git repos. I'll add a deployment of an external package to the palette. And then I'll set a feature flag to enable some optional functionality for integrating the program deployed by that palette with the OS's hostname. And then I'll stage the modified palette to be applied on the next boot. And after a reboot, the hostname is now auto-generated from the Pi's serial number. If I want to share my changes online, I can push the modified palette up to a new repo on GitHub. For this demo, I'll just switch to the development branch of the palette I maintain for the plantoscope project. After rebooting, we can see that the Raspberry Pi is accessed at a different domain name set by the OS config files deployed by Forklift, and that the web app previously served on port 80 has been replaced by this landing page I made for the plantoscope, which links to various other apps deployed by Forklift. We can also see that the Pi is now running a lot more Docker containers. Finally, we can add package deployments from arbitrary Forklift package repositories. But if we try to add a package deployment which conflicts with one already included in the palette, we can see that Forklift prevents us from applying it, since that would take our system into an invalid state. And similarly, Forklift prevents us from applying the palette if we removed a package deployment which provided a resource required by another package deployment, unless we replaced it with a different one providing that same resource. This just scratches the surface of what I've done so far, so if you're intrigued, you can try Forklift yourself from my guided demos on GitHub.